Okay, let's give you guys some more practice. So find the radius of convergence and the interval of convergence for this power series. Let's have a go. Okay, so to do this, we're going to use the ratio test. So when it comes to the ratio test, we always need to compute this value. an plus 1 gets your an plus 1 divided by an. So now if you look at this here, look at this block and look at this block. These two combined together will either be minus 1 or it's going to be 1. But when you take the absolute here, so the absolute of this will be 1, the absolute of this will be 1. 1 times anything is the same thing. So you immediately get rid of these two blocks. Because you've got the absolute here, you've got an absolute here, you don't care if it's negative 1 or it's positive 1. So immediately ignore these two. So from here, that will then take you to here. Now, hang on. So now visualize this block here as being 4 to the power of n times 4. Visualize this as being x to the power of n times x. So now this thing here will cancel out with this. And then 4 to the power of n will cancel out with 4 to the power of n, leaving you with n plus 1. Then you've got your n here, and then you've got your 4x here. And because n is always positive, you can get something that's always positive. This will be this basically. And then now for convergence, when it comes to the ratio test, for convergence we require this to be less than 1. So we require this to be less than 1. But then if you look at this, as n heads towards infinity, this is going to head towards the number 1. As n heads towards infinity, this block here will be 1. So you trying to make this to be less than 1 is really you trying to make this to be less than 1. The minute this is less than 1, then the whole thing here will be less than 1. So for convergence, we require this to be less than 1. So for convergence, we require this to be less than 1. Now translate this. So whenever you see this, you can always translate it to this. Everything by 4, so that will then give you this. So we know that anything in between negative 4, negative a quarter, and positive a quarter, we know for sure anything in between, then our power series will converge. Anything in between, but then that on negative a quarter and a quarter, that on negative a quarter and a quarter, this thing here will be precisely 1. But then when it comes to the ratio test, if this thing here equals 1, then it's inconclusive. So we need to manually check. So now to check it, when x is negative a quarter, put it into here. That will then give you this negative. And then you've got this thing to the power of n to the power of n. So that means you can just simply get this times this. 4 times negative a quarter, that will then give you negative 1. Now if you look at this, n, which means you can just get this times this, that will be 1. This whole thing here will be 1. And then you can see as n heads towards this should be, bear with me, this should be equals to 1, equals 1. So as n heads towards infinity, this is just going to get bigger and bigger and bigger, meaning the whole thing here is going to diverge. So now let's look at the case when n equals positive a quarter. So positive a quarter, going back to our original power series, we put this into here. That will then give you a quarter. That will then give you 1, and then n, same power. You can just simply get this times this. That will then give you negative 1 to the power of n. Don't get confused with minus 1 to the power of n, 1 over n. Don't get confused with this. This is n here. So n is just going to get bigger and bigger and bigger and bigger Yes, it is alternating, but it's getting bigger and bigger. So it's like this. It's you add, take away, add, take away, add, take away. It's just going to diverge. It's just going to get bigger and bigger and bigger. So this thing here is going to diverge, even though it's alternating. Uh, because of this, it's going to diverge. We've done this many times, so you should know this by now. So overall, the radius of so that on negative a quarter, we know it's going to diverge. That on positive a quarter, we know it's going to diverge. Convergence is while the radius of convergence is a quarter, and the interval of convergence is excluding negative a quarter. So excluding negative a quarter and excluding positive a quarter. So the radius of convergence is actually this.